Hi everyone. Today we're going to study numerical integration. In engineering and science, it is frequently hard or tedious to evaluate the problems of definite integrations. In here, we will study some of the numerical methods to find the numerical value of the definite integration without integrating it actually. As we know, the definite integral, and that is the integral from a to b of the function f of x dx, is equal to the area between the graph of the function f of x, the x-axis, and the vertical lines x equals a and x equals b, as shown in this graph. Extending this idea in the numerical integration by dividing this area to some shapes and collecting the areas of these shapes to get an approximated value of the required integral. On this topic, we will discuss two tools for approximating a definite integral to any degree of accuracy. There are two methods. The first is trapezoidal method, followed by Simpson's method. These tools are used to evaluate definite integrals when the integrand has no simple antiderivative. Moreover, we sometimes only have information about a function by making observations at a certain number of data points and no available formula for the function we are integrating. We shall discuss the two methods on the next videos. Today we're going to study trapezoidal rule. In this method, we divide the area enclosed by f of x, x-axis, and two vertical lines, x equals a and x equals b, into n plus 1 trapezoids, having equal width, that is h. Look at this illustration. On top is the graph of y equals f of x. Below is the x-axis. On the sides are the vertical lines x equals a and x equals b. Look at the x-axis. We have some arbitrary numbers. So we have a, then x sub 1, x sub 2, x sub 3, x sub 4, up to x sub I. Then we have x sub n minus 1. And the last is b. In here, the a is considered to be x sub 0 and b is x sub n. This is now the formula of trapezoidal rule. The definite integral from a to b of the function f of x dx equals h over 2 times the quantity y sub 0 plus y sub n, which means the y values corresponding to the first value and the last value, plus the constant 2 times the sum of the y values of the corresponding x values. In this formula, the h or the equal width is equal to b minus a over n, while the n is the number of equal parts or the number of trapezoids between a and b. Look at this example. Approximate the integral, the definite integral from 0 to 1 of the function x squared plus 2 dx using trapezoidal method with n equals 8. The step 1 is to list the given values. First, we collect the y is equal to the function x squared plus 2. Then, the lower and upper limits respectively. A equals 0 and b equals 1. And the n is given as 8. Step 2, let us calculate the width h. Our formula, b minus a over n. So we substitute like 1 minus 0 all over 8. Simplifying this, we will get the decimal 0.125. Step 3, let us complete the table of values. So we have here two rows for x and y respectively. In here, we're going to write n plus 1 columns. So we have n as 8, so we will write here 9 boxes or columns. In the first box for the x, we will write the value 0, that is the a, and the last box is the number 1, that is the b. In between, we're going to fill the values. In doing so, we're going to take this value 0 added to the value h, and we will get the value here. This value plus the h, that is equal to 0.250. This value plus the h will get 0.375. This value plus the h, it becomes 0.5. This value plus h becomes 0.625 and so on. Now let us get the values for the y. We're going to use this formula. So for the first box, we're going to write this as y sub 0 equals substituting the value of x. This is 0 squared plus 2, and this is equal to 2. Let us write this on the blank. Let us get the value of y on the last box here. So that will be y sub 8, and this is equal to the value of x is 1, so we have 1 squared plus 2. This is equal to 3, and we copy it in here. That is the y sub 8. Now, we're going to fill the remaining values of y using this pattern. So it becomes like this. Now step 4, we're going to use the formula. Then let us substitute the corresponding values. So our h is that 0.125 over 2 times the quantity, this y sub 0 plus y sub n, in this case y sub 8. So we write here 2 plus 3 plus the constant 2. We copy it here, multiplied by the sum of the remaining values of y. Using our calculator, we can simplify this value into 2.3366. This is now the final answer. Today we're going to study Trapezoidal Rule Part 2. Let's begin with absolute error and relative percentage error. We let capital A be the estimated value and capital B equals exact value. For the absolute error, the formula is absolute value of A minus B. For relative percentage error equals absolute value of the fraction, the numerator is A minus B all over A, multiplied by 100%. Let us see this example. Approximate the integral, definite integral from 0 to 2. The function is 1 all over 1 plus x squared, then dx. Using trapezoidal method with 8 sub-intervals. Also, find the exact value, absolute error, and relative percentage error. First, let us solve this problem by trapezoidal rule. The step 1, we're going to list the given values. The function or y equals this 1 over 1 plus x squared. Then we write the limits a and b. The values are 0 and 2 respectively. The n equals 8. Step 2. Calculate the width h. Our formula is b minus a all over n. Substituting the values, we have 2 minus 0 all over 8. We simplified this into 0.25. Now step 3. We're going to complete the table of values. We have here a table with 2 rows. First row for x values, second row for y values. For the columns here, we're going to write n plus 1 number of columns. Our n is 8, so 8 plus 1, we should write here 9 columns. Let us complete the x row. The first blank here is reserved for the value of a, which is 0. The last blank of x is reserved for the b, which is 2. Now let us complete the remaining values. The next blank here is equal to the 0 plus the value of h, which is 0.25. Next value, 0.25 plus the h, which is 0.5. 0.5 plus the h, 0.75. So that pattern will continue up to the last value. Now, for the y values. We regard the first one to be y sub 0, y sub 1, up to y sub 8. Let us now find the values of y. We're going to use this equation. The y equals 1 over 1 plus x squared. Let's begin with finding the y sub 0. Using this formula, we have now y sub 0 equals 1 all over 1 plus 0 squared. This 0 is the value of x in here. Simplifying this, we have now 1, and this value we're going to substitute in here. Let's proceed with finding the y sub 8. Using the same formula, y sub 8 equals 1 all over 1 plus 2 squared. Simplifying this, we have 0.2, and we substitute this value in the blank. We can complete the values of y using this pattern, and these are the values. I put here some examples of solutions. Now, the table is complete. We can now proceed with step 4 using the formula. Here is now the formula for trapezoidal rule. We'll simply substitute the corresponding values, and it becomes like this. And from here, we can use our calculator to find the final answer, which is 1.1063. So that is the problem A, solving this integral by trapezoidal rule, and the value is 1.1063. And we consider this to be the estimated value. Now we're going to get the exact value. In here, we're going to use the integration formula. The integral of 1 over 1 plus x squared dx is equal to the inverse tangent of x. And we are going to evaluate this with respect to the limits from 0 to 2. We can now substitute, and it becomes the inverse tangent of 2 minus the inverse tangent of 0. We can use our calculator to find the corresponding values, but make sure that calculator must be in radian mode. So the values are 1.1071 minus 0 respectively. And the final answer is 1.1071. We can write the answer in here. Then the absolute error. Our formula is the absolute value of exact value minus approximate value. So let us substitute the corresponding values in the formula. So we have the exact value is this 1.1071, we write it here, minus the approximate value or estimated value, the 1.1063. When we get the difference, the answer is 0.0008. And the absolute value, simply we remove the symbol. So the absolute error is 0.0008. Then we go to the relative percentage error. That is our D. And this is the formula. Absolute value of this fraction. Exact value minus approximate value all over exact value multiplied by 100%. Let us substitute the corresponding values. So we have now the absolute value of the fraction. The numerator is 1.1071 minus 1.1063 all over 1.1071 times 100%. Let us simplify the numerator. That will be the 0.0008, then divide by 1.1071. When we simplify this fraction, it becomes 0.00072. And since the answer is positive, we can remove the absolute value symbol. Then we multiply by 100%. So the answer now is 0.072%. This is the relative percentage error.